Hello, my little mathematicians. Today, we are going to be focusing on subtracting fractions or mixed numbers. So first of all, let's review the steps that we're going to use. When you're subtracting fractions, just like when you're adding fractions, you always want to get a common denominator. To find a common denominator, that's essentially finding the LCM, or least common multiple, because it's the smallest thing that both denominators can multiply to become. You'll also sometimes see it referred to as the LCD. The LCD is still just the smallest common denominator. After you find your common denominator, you're going to use it to rewrite equivalent fractions to your original ones. Okay, and we'll go over that once we start doing some examples. Then you subtract the numerators and don't forget to also subtract the whole numbers as well out in front of your fractions. And then your denominators stay the same. You're pretty much done at that point. It's just the last thing you need to remember to do is always to simplify. And simplify means you're either reducing if it can be reduced or changing any improper fractions to mixed numbers. Let's go ahead and try some of these. Okay, the first thing I need to do is find a common denominator. Well, they're both the denominator of 9, so I already have a common denominator. I'm going to keep it the same. Then you subtract your numerators. So 7 minus 4 is 5. Think to yourself, can I reduce that? Is it improper? No to both of those questions? Then you're done. Let's move on to a little bit more complicated. Number 2 has a denominator of 8 and 10. Are those common? No. So to find a common denominator, again, I said that we could do the LCM. So 8 and 10, 2 can go into both of those. 2 goes into 8 4 times. 2 goes into 10 5 times. I can't keep going, so I multiply the outside numbers. 2 times 4 times 5. 2 times 4 is 8. 8 times 5 is 40, which means the smallest number that both 8 and 10 can multiply to become is 40. That's their common denominator. I'm going to rewrite equivalent fractions to 5/8 and 1/10, but with denominators of 40. 10 times 4 is 40. So do the same thing on top. 1 times 4 is 4. 8 times 5 is 40. So do the same thing on top. 5 times 5 is 25. Now that you have equivalent fractions to your originals, I keep my denominator the same. My denominator was 40. It's going to stay 40. And I'm going to subtract my two numerators. 25 minus 4 is 21. Can I reduce that? No, nothing can go into both. Is it improper? No, so I can just keep it as is because it's proper. Okay, my next one. Do they have common denominators? Nope. So you could do the ladder method, or if you do it in your head, look at the bigger number 24. Can 8 become 24? Yes, it can. So then 24 is what they both can become. You could have also done it in your head with these two as well. Look at 10. Can 8 become 10? No. 10 times 2 is 20. Can 8 become 20? No. 10 times 3 is 30. Can 8 become 30? No. 10 times 4 is 40. Can 8 become 40? Yes. So they both can become 40. So you can always do that process in your head if you don't want to use the ladder method to find your LCM. Okay, now that we have our common denominator, let's rewrite equivalent fractions. 24 times what is 24? 1. So 17 times 1 is 17. 8 times what is 24? 3. So 7 times 3 is 21. Now that you have equivalent fractions, subtract your numerators. 21 minus 17, let's borrow. 11 minus 7 is 4. 1 minus 1 is 0. So you have 4 over 24. Don't forget your whole numbers. 12 minus 5 is 7. And then always double check. Can I reduce it? I sure can. 4 can go into both of these. If you didn't see 4 right off the bat, if you just saw 2, you would have divided by 2 and then divided by 2 again. Okay? Regardless, you still would have ended with 4 divided by 4 is 1. 24 divided by 4 is 6. So you would have ended with 7 and 1/6. For my next one, yes, they have a common denominator. So I want you to go ahead and try this one. Okay, now that you unpause the video and you're back with us, you kept the denominator the same. Now subtract those numerators. 7 minus 2 is 5. Subtract the whole numbers as well. 10 minus 4 is 6. Can you reduce it? No. Is it improper? No. So you're done. Okay, for the next one, and of course, even though I said pause it last time, you can always pause it at any point in time, try it yourself, and then come back and join us. Okay, these have common denominators already, so let's keep the denominator of 5. Then when you go to subtract your numerators, 3 minus 3 is 0. We'll talk about what that means in a second. And 72 minus 63. Borrow. 12 minus 3 is 9. 6 minus 6 is 0. So you have 9 and 0/5. Well, 0/5 means you don't have any fifths. There's nothing there. So 9 plus nothing is just 9. It was so easy that it was hard. All right, our final one doesn't have a common denominator. If you want, you can pause it and try it yourself. Okay, now if you're back with us, what can 2 and 5 both become? Can 2 become 5? No. 5 times 2 is 10. Can 2 become 10? It sure can. So they both can become 10. Or you did the ladder method. They don't have anything in common except 1. 1 times 2 is 2. 1 times what is 5? 5. And 1 times 2 times 5. 1 times 2 is 2. 2 times 5 is 10. So you still would have gotten 10 as your common denominator. Okay, let's rewrite equivalent fractions with common denominators of 10. 2 times what is 10? 5. So 1 times 5 is 5. 5 times what is 10? 2. So 3 times 2 is 6. Always double check your sign. We're subtracting. So 6 minus 5 is 1. Keep your denominator the same. And then subtract your whole numbers. 14 minus 8 is 6. Can I reduce it? No. Is it improper? No. So you're done. Congratulations. You now know how to subtract mixed numbers.